Hello and welcome to Saurabh's classes. In this video, I am going to solve many MCQs regarding the estimation and test of hypothesis. So the chapters are basically estimation and test of hypothesis. I have already covered many questions regarding this chapter in my previous video. So this time I am starting from question number 27. Given the sample size, if we try to reduce the probability of rejecting the true hypothesis and we at the same time increase the probability of accepting the false hypothesis, so which of these statement is true? Now, by type 1 error, which is the first part of the question, we mean that the probability of rejecting the true null hypothesis. And by type 2 error, we mean the probability of accepting the false null hypothesis. Now, type 1 error is defined by alpha and type 2 error is defined by beta. So, by 1 minus beta, we say this is the power of the test. Therefore, the problem is we cannot reduce the two error simultaneously. And that is precisely problem. We first give priority to reduce the type 1 error. Therefore, the type 2 error beta increases. So, this statement is true. Option C is the correct answer. Question number 28 says that the lowest level of significance at which H naught is rejected is determined by the t-value, p-value, significance test and confidence interval. So, nowadays in the statistical software packages, we do not get actually the value of alpha or the value of test statistics. So we do not get actually the value of alpha, so the critical region, but rather than we get the p-value. So we get p-value. So what is p-value? It is the lowest level of significance at which H naught is rejected. Suppose alpha is equal to 0.05 and 0.01 and 0.10. Now we can write it like this. So alpha 0.10, then alpha 0.05 and alpha 0.01. So this is the critical region for alpha 0.01. For 0.05, this entire region is the critical region, and for 0.10, this entire part is the critical region. Now, as we can see, for this part, if the H naught is rejected for alpha 0.01, then for all above values of alpha, H naught is also rejected, as it surely falls in the critical region. So therefore the p-value here will be 0.01. Question number 21 is for t-test and f-test, particularly in a small sample, we require the error terms to follow: t distribution, f distribution, normal distribution, and chi-square distribution. So for the t-test, the test statistics is normal distribution divided by the chi-square distribution with the degrees of freedom. Whereas for the f-test, it is the chi-square distribution with degrees of freedom. Suppose the degrees of freedom for the first chi-square distribution is m and the second chi-square distribution is n. So it is just a ratio of two chi-square distribution, and it is known as the f statistics. So for this test in a small samples, we required the error term to follow the normal distribution. The question number 30 is that a rule of thumb for resulting the h0 of the slope coefficient being equal to 2, the 5% level of significance, you should do what among this? So suppose my model is something like this, the specification of a two variable model. So yi equals to beta 0 plus beta 1 x1 equals to ui. So our slope coefficient is beta 1. So the h0 is beta 1 equals to 2. So how to form the test statistics? Suppose the test statistics is something like this. So h0, the test statistics, so it's beta 1 hat minus 2 divided by the standard error of beta 1 hat. So this is the thing. So the first thing, the subtract 2 from the estimated coefficient and divide the difference by the standard error and check whether this statistics is greater than 2 in the absolute value. So only then the, as it is greater than 2 though, so the alternative hypothesis is beta 1 greater than 2. So the first option, and the rest options are C, the slope coefficients between 0.95 to 1.05 and the r square, and the divide the slope coefficient not subtracting 2, because we have set beta 1 equal to 2, so we need to subtract the mean value from it. So therefore the option 1 is the correct option. Question number 33 is the Jarque-Bera test is a model specification test, residual normality test, the test for unbiasedness estimator, and the test of goodness of fit for the model. Now the Jarque-Bera test basically tests whether the data has skewness or kurtosis. So basically it is a checking for normality, and therefore the correct answer is the residual normality test. Question number 34. The normality of error term is essential for the hypothesis testing, and this statement is always true, sometimes true, always false, and can't say. If the error term, suppose epsilon, is not normal, then the mean of the error term is not 0. And if the mean of the error term on an average is not 0, then we cannot use this model for prediction. Therefore, expectation of epsilon equal to 0 must be always true. So option A is the correct answer. Question number 35 states that if the estimated beta 2 hat is equal to the hypothesized beta 2, then the t value will be equal to 0, 1, 30 and the standard error of the error term. Obviously the t value, the t statistics is beta 0 plus beta s by root of n. Now if these two are equal, so the numerator is 0. Therefore, the t value will be 0. So, option A is the correct answer. So, I have solved many questions regarding the core chapters of estimation and hypothesis testing. These are the two main chapters. I hope these are useful for you guys. Till then, thank you.